So before we can do the layout of the PCB, we have to complete the BOM, bill of materials for it. Yeah, the flow is slightly different to, when you're working with mechanical component, electrical, and so on. With PCB design, you create your BOM pretty much at the same time as you are creating your schematic. The reason for that is obviously that you've got many different options when it comes to components and footprints, and also you have to check availability, making sure that the component is available. So I did attach a BOM template here, and if you open up that template, let me just open it up. Okay. This is a traditional sort of template used in many companies. So what we have is obviously, how many components, what's the reference? So this is the designators, manufacturer of the actual component, manufacturing part number, supplier, where you're getting it from, and supplier part number, description, package, and type. Now, this is a very basic version. Normally what companies would do is they would include extra columns like alternative component, alternative supplier, maybe cost, maybe something else, some other additional notes. But this is sort of a very basic spreadsheet. Now, most companies would use spreadsheets. The problem with that is that when you put your components here and you update your schematic, you have to make sure that you actually update your BOM. There is no link between your BOM and your schematic. You can export components from your schematic. I'll show you how. So I'll just close this. I don't need that anymore. And if I open up our project, which is that one there, and open up the schematic, I did open in another window for me. What I'll do is I'll make that window a little bit smaller because I don't need to see the entire schematic. If we go to, I'm missing some of the items there. Okay. So if we go into edit symbol field, again, that has opened on different screen and it's huge. I'll make it a little bit smaller. There is an option of exporting that list to a CSV file. So this is comma delimited file. It looks like this, and Excel spreadsheet can read it. So you can open up that file. You will have all your component designators, names, whatever you are exporting, it'll be there. And you can copy it into your bill of materials. Now, we're not going to do that. We'll actually use slightly different method here. Instead of having BOM as a separate spreadsheet, we'll keep the BOM with our schematic of our project. So if we go to edit and we've got our list, effectively this is our BOM. We can print it, we can export it. It is what it is. Now, what I would like to do though here is change some settings, extra fields. So reference, yes, we're going to keep that one, keep value, keep footprint. Data sheet, quite often you want to keep that. So if I turn it on, you can see that the data sheets for some components is already linked to data sheet is already in. In our case, we'll keep it simple. We won't be actually downloading data sheets, but it's always a good idea to have data sheets with your project. So if you're looking for component, then okay, this one is not available. I need to find a replacement. You can just open up your data sheet from a component, have a look at specification. It's a lot easier to find equivalent component from another manufacturer and replace it. So, but in our case, we don't, we'll just leave it out. So data sheet doesn't have to be there. Description, yes. Quantity, yes. And I want to add some extra fields there. So the field I want to add is, and keeping it simple, we're not going to go for manufacturer, manufacturing part number, supplier, supplier part number. I just want to add some links so I can quickly order those components. So I'll click on the plus here, field name, and I'll just put in supplier links. Okay, it's on. So now we do have supplier link down there. I'll just squash it a little bit so we can see what's happening. Okay, supplier links. And every time you do changes in this table, you have to apply save schematic and continue. If you don't do that and you just say OK or cancel, you'll actually lose your changes. So I'll just click on apply. That's saved. And now we can finish off this building bill of materials. And also we can correct some items which are not necessarily 100% correct. So now we are sorting by reference number, that's fine. So starting with capacitors, diode, and so on. We've got values here which are correct. We assume that they are correct at this stage. The footprints we have to verify. We have to check that we actually have correct footprints. The descriptions, we can change those descriptions as well. We'll just insert supplier links. So let's just have a look. I'll just, that's saved. Let's have a look at our, let me check that. Okay. Our suppliers. So one way of looking for components is to go into supplier websites and search for components. This is traditional way. This is normal way of doing it. In all companies, electronics companies, people who do, put it together, they'll go through and search, and I'll show you. I'll just open up those supplier links. Maybe I'll open all of them. You can always close it. And you can start with, okay, we're looking for capacitor. You can put in values, 0.1 of the microfarad, for example. You can pick ceramics or just press enter. And then you've got selections of different capacitors. We're talking about ceramics here, so click on that one. And then you've got all sorts of filters you have to filter. So one thing I always do is always go in stock. If there is a field saying, well, you want new designs, so legacy designs or whatever, you can select or deselect that. Series, unless I know exactly what I'm looking for, I'm not checking that. Packaging, because we are doing few prototypes, we're not making a big production run. I always look for cut tape because that's small quantities. You don't want to buy 4,000 of them. You just want to buy a few of them. So cut tape is good. Active, so this is always good to have an active, not discontinued. And then that's already selected because we are searching for 0.1, so we've got a 0.1 there. 100 picofarad is the same as 1 micro, so it's the same. Tolerance, not too fast. Voltage rated, I'll just leave it out because we want something which is more than 5 volts. I wouldn't go for anything less than 10. 6.3 would be fine, but just in case, I always like to upsize my voltages so there is not an issue of capacitor. When you have voltage spikes, there's no issue with voltage going over. And you can see that we still have 2,685 components there, so you can filter it a bit further. So one field I definitely want to set is that it's a surface mount, just a standard surface mount component. And I want to select my size. In this case, we're talking about 0603. In Imperial, I can't, it doesn't give me that, so that's a bit rude, I'll just clear that filter, mounting type, leave it out, and now I'll select 0603, that's the one. 500 of them, I'll just say apply. Okay, when you press apply, then you've got all your components there. I usually go by the cheapest, so just go sort. And now you've got your selections. So, for example, the first one, 0.1 micro, 16 volts, 0603, standard capacitor, nothing too fancy, 10%. Yeah, we're not too fast about it. It's good. We can just go to that capacitor, and then you can copy some details from this. But this is a slow way, and there's a better way. So what we'll do is I'll actually close all those pages. I'll go to Google, and I'll use Google search to search for specific components I want. It's much faster. You don't have filtering capabilities you've got with your suppliers, but if you are just doing a few prototypes, one-off, you don't really care about your suppliers, where's it coming from. So I'll just use Google. Don't switch. Okay. So let's have a look at our list. The first component there is the capacitor, ceramic capacitor, 0603, 1 micro. I'll just put in my search engine. Okay, here. I don't want to define anything else. So just press enter, go straight to shopping. And you already have all different capacitors coming from different companies. Now, if you are to, let's say that I want to have all my components from DigiKey because that's my preferred supplier. I've got lower shipping cost, or if I order all components from one supplier, I pay one shipping cost, not multiples. So you can restrict it always by saying, okay, it's got to be DigiKey. Press enter, and now we've got our DigiKey selection. It's not necessarily the cheapest component, but if you're doing a few items, if it costs 20 cents or 60 cents, really doesn't make that much difference. And you can always pick cheaper variety out of it all. So for example, that one there, 18 cents from DigiKey. Let's just click on that. See the parameters. It usually gives you, it's capacitor ceramic 0.1 10 volt 0603, perfect, nothing wrong with it. I'll click on that. Verify that parameters are correct. And now I want to copy the link to this page. So when I'm ordering, I can quickly order all those components. And unfortunately, when you use Google, that link, that path, it has all the Google rubbish, which is used basically to to track you for a start. It's the tracking sort of components. But also it tells DigiKey that yes, they've used Google to find this component. It's worth to advertise with us and give us some money and blah, blah, blah. So what we're going to do is I'll remove all rubbish past this question mark here, which is all Google rubbish. Press enter. And now I've got a clean path. So that path is directing me directly to this component. I'll copy that path, Control copy, go to my BOM, paste it there, and I've got my link here. So every time you paste it to something, just apply safe, make sure that you're not losing it. That's it. So next is going to be 4.7 microfarad, and it's got to be polarized. So it's there are different types. Tantalum is what we want to use pretty much. So what I want to do is I'll kill this, go here, use DigiKey again, because if I want to have all of them from one source, that's fine. I'll put in 4.7 micro, 1206 tantalum from DigiKey, enter. Here we go. We've got a few different options. They're more expensive, obviously, because it's a more expensive technology and bigger size. And pick one. Well, which one? Well, let's pick that one. 90 cents or 77 cents. Let's pick that one. Let's have a look at parameters. So 0.7 is fine, 10% is fine, 10 volts is fine, 1206, which is our size, is fine. So I'll just click there, go to the side. Again, I want to remove all Google rubbish from that string there. Enter. And now everything looks fine there. All the parameters are correct. So copy that string and paste it straight there. Okay, and save. Now LED. I've noticed that I've selected 1206 footprint for the LED, but it actually says C, which means capacitor. Not that it matters, and actually even looking at this metric pad here, it doesn't say that it's polarized or non-polarized. So let's just have a look, because maybe there is a polarized version of that. So if we look, this is just a normal one. And solder metric. Do we have? Yeah, okay. We actually do have specific footprints for tantalum capacitors, but they're not generic. They're unique. Let's have a look. So, what are the chances that they actually correct in terms of sizes? So, it's either that we look for a specific capacitor, specific name, or in this case, I probably wouldn't bother. You can see that the difference is that with some of those footprints, that yellow line here, it's finishing just like this. It doesn't have this side, and this is just showing the polarity of the actual footprint. Now, in this case, we can probably ignore this for now, and we can come back to it later if we need to. So I'll just cancel, and I'll just leave this footprint as it is. But for LED, I definitely want to change that one. So click there, and I'll just type in LED, and our footprint is, what's the size? 1206. So 1206 metric, that's the one. You can see it's polarized. It's got that yellow line finishes here. It doesn't go all the way around. I'll say OK. So it's a better footprint. Like, it doesn't really matter. 1206 is 1206. There are a few different variants when it comes to the width, but even if the width you don't get it exactly right, you can still solder it. It will still work. The main thing is indication of polarity, which in this case it's there. In this case, it's not. Yeah, we can later on replace this if we can find the right one. So I'll apply that change, and we need to find our LED. So for LED, let's go back here. And just use still DigiKey and just put in LED, and then the size, which will be 1206. And now we've got quite a few different versions. What we can do is we can actually add a color to it, because a lot of them, if we, let's say, pick this one here, that's a red one. And red one is this. Usually they've got higher voltage. They're usually about 3 volt. So indeed, it actually doesn't say that. If we go into the actual component, it should tell us forward voltage 2 volt. That's okay. Like I don't like to go for 3.3 or 3 volt forward voltage LEDs for circuits like this. I prefer to keep the forward voltage lower. But 20 milliamps standard, 2 volts, pretty good. Nothing wrong with that one. It's a red one. If you want different color, just specify different color here. Just, you know, put in what color? Green. And obviously you'll find green ones. But let's just stick to this one here, red. And yeah, I'm happy with this one, so I'll just remove that string from the back. Copy this and put it straight in there and save. Always save. Okay, ferrite bead. That's quite easy. We're going to go FB and then the size, whatever size we want. So this 0805 is the one we've picked. Quite a few different ones. Let's just pick the first one. That's the cheapest one, 18 cents. Let's just check it. So if I open it up, let's just check parameters. So we're talking about frequency, current rating 150 milliamps. That's plenty. DC resistance 1.5 ohms. That's good. It's a low value. You want to keep it as low as possible. Actually, it would be better to have it even lower, but that's still okay. Surface mount. Package size 0603. This is not what we wanted. We want 0805. So that's a wrong one. This is sponsored. That's why it's rubbish. So let's have a look at that one. Doesn't look right, but all those look, you know, okay-ish. Is this the same as that? Same price. Let's check it. So I'll just open this one. 3 amps, 0.4 DC. That one looks quite good. 0805. So let's just have a look at that one. Cut tape. 100 ohms. What you want is about 120 ohms. 100 megahertz. 0805 package is good. 3 amps. That's plenty. 14 milliohms. That's okay. So yeah, it looks okay. So I'll use this one. I'll just remove the Google rubbish from the end. Then I can now copy that link and put it straight there. Save. USB connector. I made a mistake here because I've picked USB B type connector, but then the footprint I've picked for it is an A type footprint. So that's not going to work. Of course, you know, if you pick your A-type USB-A component and place it there, not an issue. But I think in this application, USB-B type is better. And realistically, all new designs, they would most likely use USB type C, simply because majority of your mobile phones use C-type connector, and a lot of new laptops use C-type connector. So it's a very common connector and very common cable. So you can just grab your cable from your phone and plug it into that board. So that's why C is probably the most common. Saying that, USB-B is a very simple connector, which is more often used with the sort of development devices. So we just use B. So I have to change this because that's incorrect. I don't want this one here. Let's have a look what we have here. Filter, I just filter USB. Type B, horizontal, don't like that one. That's a mini B, sorry. C, micro, USB-C, mini. I'll just filter a little bit further. It's interesting because I can't find the one I want. Yeah, that's the one I want. It's a very simple 4-pin plus your shield, vertical connector, so I'll just use this one. Full name, USB-B OST, this is the supplier or the manufacturer. USB type B, this is the series, it's a horizontal connector. I'll say OK. You've got documentation there as well. OK, save it. And now, really to search for this connector, we have to search by the connector sort of serial number, not serial number, but the type. So if we go here, and I'll just use DigiKey again as my preferred supplier, and type in B1HS, which is part of the actual description for the connector. This is the specific series. USB connector DigiKey. These are the wrong ones. The A type. It's not a B type. USB connector. Unless DigiKey doesn't have one. Let's have a look at without DigiKey. See, it popped in as the first option here when I didn't put DigiKey in front of it at the back there. Weird, but that's the connector I want. A very, very standard connector. So I'll open it up. Make sure that that's the one I want. That's the series, which means it'll fit that actual footprint. 40 volts and shielded. Yeah, that's a product number. So we are fine with that one. Let me just clean this up a little bit. So question mark, I'll just run if Google rubbish and put in the actual path. Copy that. And save. Next, we've got the header pins, and sometimes they're hard to find. Like there's nothing wrong with this footprint, but sometimes they're hard to find. So I'll just use that name there, mail pin header, copy that, place it here. So this is the header we want, but some of them are like, this is the 40 pin header, so it's got 40. We want 10 because we've got 4 10s. We can either buy 40 and break it, you can cut it into pieces, but I'll just put in 10 positions. 10 positions. And yeah, that's a DigiKey version, and hopefully that's 10 positions. Let's have a look. Six positions, that's not the one. So obviously the sponsor results don't give you what you want. Oh, let's have a look if I can actually say that it's got to be from DigiKey. Pin header doesn't tell me how many positions, but I can just open the two and just see which one is 10 positions. 6 positions, rubbish. How many positions is that? Doesn't 8 positions, rubbish. Yeah, sometimes it's hard to look for, you're looking for simple thing and it's so hard to find the right one. 10 positions, okay, that one might be okay. Okay, so that's a standard header. It looks okay visually. 10 positions, 2.54 millimeters pitch, so that's all good. Yeah, so that one is fine. 30 cents, not a huge deal. Let's just remove all the Google rubbish and this is my path. Copy that and place it here, save. Next, we want the programming connector. And for programming connector, we basically have to say that, well, it's, just have a look here. I mean, you can try to search directly here, but this search is not as good. So if we say ADC header 2x3 vertical, is it going to give me what I want? No, it doesn't. So I use Google for that. It's a lot better. Saying that, the future is with AI, which means AI searches will soon replace Google and other, or Google actually start using AI. They'll be a bit more intelligent. So let's just see what we can find here. Easy. And see, if I put the same string in Google, it'll find me DigiKey part. If I put this into search field in DigiKey, it won't find the part. So that's why I'm using Google Shopping, because it's just quicker. So that one is perfect, 6 positions. It looks exactly what it should look like, 2.54, not an issue. I'll open it up. Yep. I can't see any issues with it, so I can just use that link. Remove all the Google rubbish from there. And now copy the link. And save. Don't forget to save. Resistors. Okay, so we're using footprints are SMDR, so they're all correct. Sizes, we're using 08, 05 for everything pretty much. So that's all good. So I'm going to just put in my 330R 0805 resistor first. Here it is. That one looks fine. Open it up. And let's have a look. SMD 330 ohms, 1%, 1/8 of the watt, 8085. Perfect. Nothing wrong with that one. I can now remove that string there and just use this as my link. Copy. Okay. The second one is 27R. So I can just change this to 27. And again, that's the cheapest one. Not it makes that much difference, but if I open this one up, let's have a look at it. The 27 ohms, 1%, 1/8 of the watt. Yeah, that's fine. 0805. I can't see issue with this one. And if this, and yeah, in the classroom, I'll tell you a little bit more about using AI and search engines. So I'll copy this, paste it there. The third one is 10K. So I'll just put in 10K or 805, same size. Here we go. That's the cheapest one, I guess. Let's have a look at it. The price of a component, if you always go for the most popular, the easiest to get components. So that's thermistor. Okay, so that's not the resistor. So obviously that's an incorrect one. You'll have to go for something a bit more expensive. Let's have a look at more products. That one there, Murata, that looks good. Let's just open it up and just check exactly that this is the one we want. Capacitor ceramics, yeah, it's in picofarads, but that's the same value, 100 volts or 805. That's fine. Bit weird description there, but it's still it's going to do the job. Or we can go for a bit more expensive one. That one is nice and flat. 1%, half a watt. So that one gives you a bit more wattage as well. 10K, 1%, half a watt. It doesn't really matter which one we pick. Cheap resistors, more cheaper, thick film. Yeah, if we use this one or the other one, it doesn't make any difference. I'll go for this one. I like this one. I'm just messing up with you. That's all. Okay, copy this. Paste it there. Now, the switch. And the switch is Omron B3FS. So this is the actual, if I go here, that's the description of the actual switch. So I'll just copy that. And see if DigiKey does have the switch. Yep, mouse DigiKey, yeah, they do have it. Yeah, that is slightly different versions there. It doesn't really matter which one you use. The first one, the second one, that one looks good. So I'll pick that one and open it up. Tactile. What I want to check is that, yeah, that's the series, which means the footprint should fit. It's a very low profile one. And the outline is 6.3 by 6 millimeters. So that should be okay. 6 by 6 or 6.3, it will still be okay. And because it's B3FS, it will fit that footprint. So I will remove that rubbish. Copy that, place it here. Now that chip there, this is the FTDI chip. We can do the same, have a look at it. And it gives you more options which are not necessarily what you are looking for. So we have to actually add the SSOP, which is the package. This is the actual package size. Now that's better. Obviously, it will give you the board with it as well, but we're talking about individual chips. Now, DigiKey, yeah, they're quite expensive. You can see, over $8. And quite frankly, I would not use it in my design. I would go for much cheaper CH340 chip. But for this exercise, we're using FTDI, and then for next exercise, we actually use a better, cheaper Chinese option. So I'll open it up. And we have to check parameters. So this is USB 2. It's not too fast. We don't need anything fast in this case. Voltage supply is fine. 3.3 to 5.25. 15 milliamp. Doesn't take much power. 28 SSLP. This is the package, so it's all good. I'm going to copy that link now. If I can find, yeah, that's a question mark there. Enter. And I'll just copy this and place it right there. And the actual processor is the last component there. So I'll just save this. Put in our processor, and yeah, DigiKey, that's the chip. 8-16AU, that's the specific version of the chip. So, and it's $5 again. Very expensive for what it is. I mean, this is a rock bottom, very, very simple processor, and you know, charging $5.40 for something that simple and that old-fashioned is a bit much. I usually use different microprocessors. I use STM, and they're much cheaper and much more powerful. I would use, you know, 32-bit processor instead of 8-bit processor, and pay, you know, $1 for it. Anyway, this is what we are using here, a microchip basic processor, and everything looks okay there. It's an active in development, so it's not discontinued. All parameters are right there. TQFP footprint is right, so that's the one. I'll remove this again. Copy this and paste it here. And save it. Now, we've just completed our, I'll just minimize this. We've completed our BOM. It's not, strictly speaking, official BOM, but it is linked to our schematic, it's linked to our project. You can order from it, you can export it and order using that BOM. You can put extra columns, extra details if you need to. There's nothing wrong with it, especially if you're doing something like a prototyping board, or in this case, development board. Having BOM as simple as this is perfect. You don't need anything more complicated. You don't need to have multiple sources, multiple suppliers, and you don't have to look for the cheapest component possible when you're building one off. So that's pretty much done. Make sure that you apply, save, and OK, and save the actual schematic. So I'll just go save here, and everything should be allocated properly. Now I'll show you how you can export this information out. So if we go back to our editor there, we've got all our fields there, and supplier links. It was off, so turn it on, make sure that it's on. And now you go to export field. This is all the information right there. Output file. Let's just go into exercises and just call it 80 development board CDS. In this case, extension is obviously automatic, but you can put in that this is BOM if you wanted to. So I can just put BOM there, go save. And do you want to save relative path? Yes, that's okay. Saved. And okay. Now, let's have a look at what we got. So if I go to my exercises, and I've got a couple of CVSs. This is the old one, and where's my new one? I think maybe I've saved it into, oh yeah, XLS. No, I lost it. Interesting. That's the old one. I'll just delete this one. I'll delete this one. Schematic log, okay. And let's export it again. What happened there? I wonder. Simple fields. This is what we've got. Export. Let's just make sure that we've got it in the right folder. So we've got it here. CDS. I'll keep that name because maybe you didn't like it then. Relative, yes. Oh yeah, then you have to say export, rolled output, okay, and then you say okay. I'll save that and okay. So it's a little bit awkward because normally you would think that it will save it automatically, but now you've got to actually press that button there. Okay, done. So let's have a look at our file manager. Yep, now we've got this file and it's new. If I open it up, just double click to open. It opens it up like this. So obviously it's not formatted Excel. And it's a CDS file, which means that you now need to save it as Excel. Now, if you want to, you can compact those and make them sort of C1 to C10 and so on, but this is just listing individual components. But all information is there, including description and including our supplier links. So now, if you are after those components, what you need to do is just no, there's no link as such, so what you can do is you can just copy that link, go into your the Internet Explorer, paste it in, and you'll get directly to the components. You can turn those into links, but too much hassle. Just text is fine at this stage, and you have to go File, Save As, and make sure that you pick your extension as Excel Workbook, and that'll save your modifications to the layout and titles, whatever you need to do. Also, it'll allow you to do links, proper links. So yeah, we've got the same path. Path is okay. XLS, save. Close it. And now you can see that we also have Excel spreadsheet. I'll open it up. The computer is a little bit slow. And here it is. So now you can turn this into links if you want to. Done, job done. And everything seems to be correct. Now, still that footprint there, we may actually look at it, but for now, let's just leave it as it is. Okay.